These are the Precalculus section 1.7 class notes examples. And again, please make sure you take a look at these learning objectives, read through the e-text to get a good feel, see lots of other examples, take some notes, and then come here and make sure you look through my notes and examples and make sure you have a good understanding. So in this section, we're looking at combinations of functions and composite functions. Combinations of functions, we mean like f plus g, f minus g, f times g, f divided by g. A composite function is your f of g of x. That looks something like this. Okay, that's the notation, and we'll talk much more about that in just a second. Okay, so find the domain of a function. The domain of any function is the largest set of real numbers. So the largest set of x's for which the value of f of x itself is real. So all I really want you to do in this class is to look to exclude some numbers. And the two things that you need to look for are division by zero. Any number that would cause us to divide by zero is bad, and or take an even root of a negative number. Okay? We can't take an even root of a negative number. You can't take the square root of -3, right? There is no such thing. Okay, so in this first example, let's look at f of x equals 1 over x minus 2 minus 1 over x plus 3. So in this function, all I have to do is look and determine where will I ever have a denominator be 0? I can never divide by 0. So notice in this first guy, x can't be 2. And in the second guy, x can't be -3. So that means I want to include every other value of x except 2 and -3. So when I write the domain, and what they want you to write in my math lab is interval notation. So we say every number but 2 and -3. So that's minus infinity all the way up to -3, except I can't include -3. So I put parentheses. Union, okay. Union means or. So or, it's in -3 to 2, not including those because I can't include -3 or 2. Or, so union, 2 to infinity. Again, not including 2. So that's the entire domain. Just a quick additional example here. F of x equals 5x divided by the square root of 24 minus 3x. Oh gee, I see I quickly made a mistake here. First of all, I'm saying to myself, 24 minus 3x can't be 0. And then inside of it, it also has to be positive. So this should have said strictly greater than 0, not greater than or equal to 0. I apologize. This should have been greater than 0. So then when I solve for x, I see that x has to be less than 8, right? When I divide by this -3, I switch the order of the, I switch the direction of this inequality. So x is now less than 8, not less than or equal to, because I'm saying this is only strictly greater than 0. So my domain should be minus infinity to 8 with an open parenthesis, not including the 8. Okay, algebra of functions or combining functions is like this. If I have f plus g of x, that means add the two. F minus g, subtract the two. F times g of x is f of x times g of x. And this quotient, f divided by g, means f of x divided by g of x. Of course, g of x can't be 0. Now, when you look for the domains of these guys, you want to look for the domain of where these functions intersect. In other words, the intersection of their domains, I apologize, the intersection of their domains. So when I look at the domain of f of x, the thing I have to make sure is that this denominator is not 0. So I look to see where it's not 0. So basically, as long as x is not -4 or 4, when I factor x squared minus 16, that's x plus 4 times x minus 4. So if x were -4 or 4, it would be 0, and I can't have that. So the domain of f of x would be minus infinity to -4, union -4 to 4, union 4 to infinity, not including any of these endpoints. Now what about the domain of g of x? Well, the denominator for g of x, x squared minus 4, can't be 0. So x plus 2 times x minus 2, that guy can be factored into that. That can't be 0. That means x can't be -2 or 2. So it can be any other number though. So the domain of g of x is minus infinity to -2, not including -2, union -2 to 2, not including 2 or -2, union 2 to infinity. So what's the intersection of the domains of these guys? Well, that means x can't be -4, 4 or -2, 2. So if I write that all out this way, there's my interval notation for the intersection of those domains. In other words, I can't include any of these 4 values of x here. That's how I have to write it in interval notation. So f plus g of x has that domain. F minus g of x has that domain. F times g of x has that domain. F divided by g of x has that domain. In addition, this denominator, f of 5x minus 4 over x squared minus 4 can't be 0 either. That means the 5x minus 4 can't be 0, which means that x, when I solve for x here, x can't be 4/5, right? X cannot be 4/5. So now I have to, when I do the intersection, I also have to include that we can't include 4/5. So it gets kind of long, but that's my interval notation. All right, composition of functions. Composition of functions is denoted f of g of x. You know, it looks like fog almost, but it means this, f of g of x. You take g of x and plug it into f of x. Okay, so the domain of the composition of functions, f of g of x, is the set of all x, such that x is in the domain of g. So first of all, we have to check the domain of g, and then only choose x's that are in the domain of g such that g is in the domain of f. So when I look at this example, f of x equals minus x squared plus 3x minus 4, and g of x is 2 minus x. Both of these are polynomials. Their domains are minus infinity to infinity. So f of g of x means take g of x, everywhere I see an x in f of x, plug that in. So f of g of x would be minus the quantity 2 minus x squared plus 3 times the quantity 2 minus x minus 4. And then you could simplify that and you get minus x squared plus x minus 2 after simplification. So the domain of that composition of functions, because the domain of both of these is minus infinity to infinity, is still minus infinity to infinity. Now when I look at an additional example here that I set up for you, I wanted to look at something a little more complicated. So now if I look at the domain of f of x, we see that x can't be 1. So that means minus infinity to 1, union 1 to infinity, not including the 1's. G of x, I see that the domain would include all x except it can't be 0, because it can't divide by 0 here. So that's minus infinity to 0, 0 to infinity. So I know that when I do my domain for f of g of x, which here you can run through the calculations and see what you get for f of g of x. Pretty simple calculation. But I'm worried about the domain. Make sure you understand the domain. So for the domain, you can only have x's that are in the domain of g to begin with. So we can't include 0. Now we have to see which x's in the domain of g allow us to have g be in the domain of f. Okay, so for x's in the domain of g, that means minus infinity to 0, 0 to infinity. Now for g of x to be in the domain of f of x, right, that means if I put g of x into here, 3x, this 3 over x, 3 over x minus 1 can't be 0, right? Here, 3 over x minus 1 can't be 0, which means 3 over x can't be 1. Solve that for x. That means x can't be 3. So that means x cannot be 3. So x can't be 0, and it can't be 3. So here's how I write it in interval notation. All right. Example 4, I just want to make sure you understand how to do f of g of x one more time. So f of x is 4 minus x. G of x is x squared minus 2x plus 5. F of g of x means take g of x, plug it into f of x everywhere I see an x. So f of g of x would be 4 minus the quantity x squared minus 2x plus 5. Simplify to get minus x squared plus 2x minus 1. Then I want to find all values of x that satisfy f of g of x equals minus 4. So here's f of g of x, it equals minus 4. That means I can have a quadratic equation to solve, right? Add 4 to both sides. Minus x squared plus 2x plus 3 equals 0. Usually we like to have the coefficient in front of x squared be positive, so when I try to factor, it's easier to think about. So you can multiply through by minus 1 to get x squared minus 2x minus 3 equals 0. That's easily factored into x plus 1 times x minus 3. So x is equal to minus 1 or 3.